I don't know if that's any better. All right. Okay, similar polygons. So when a polygon is an enlargement or reduction of another polygon, we say that they're similar. And the reason why they're similar is that they will increase by the same amount on all the sides. That's how you know the corresponding sides increase. So A to D matches WZ. You guys would agree with that, right? Like this side, A to D. So when I say corresponding sides, I'm talking about those two things. Like the smaller one matches the same side on the bigger one. So corresponding sides have lengths that are proportional. So it means that they increase by all the same amount. So if this was 3 and this one was 9, what's my scale factor? Can you guys calculate the scale factor? Assuming that this one is the original and this one is the drawing. So if you're not sure how to do that, those would be the formulas from the very first lesson that we did. So scale factor is equal to the drawing divided by the actual. So what's the scale factor? Well, even thinking about it this way, what do I have to multiply 3 by to change it to 9? 3. So the scale factor is 3, because we would take 9, we'd divide it by 3, and we would get 3 for an answer. So we know the shape is similar is if every side is increased by 3 times. So what's 5 times 3? 15. Is this side 15? Yay, us. If this side was 6, what's 6 times 3? 18. So this side, 18. Look at that. Life's getting good. And what's 4 by 3? 12. And this is 12. So we would say that these shapes are similar because they all increase by the same scale factor. So if you need to know how to calculate scale factor, you need to know these formulas. So you need to make sure that this is on your cheat sheet so that you can use it later. Okay, so let's match up the sides. So I did the yellow. So we know that AD corresponds to WZ. And so if I went from A to D, I'm going to go from W to Z. Would you be wrong if you wrote ZW? No, but we like to keep it grammatically correct. Okay, next one, A to B. Where does A to B match? W to X. So that's that side right there. I'm trying to get some more colors happening here. Of course, it's going to be all these colors. Okay, and then I have BC. BC is here. And what side does that match? XY. And sometimes I like putting colors on them just to help remind me that those things. And then my last one's going to be DC, and that one's going to match the bottom here, so ZY. So if you started on the left and went to the right, you went DC, then you should start on the left and go to the right for the bigger shape. Okay. So now it talks about corresponding angles. So these are our vertices. Those are the corners of the diagram, and they're represented by letters. So if we start with angle D, so I'm going to make that shape angle D, and that corresponds with what letter in the big diagram? D goes to Z. Angle Z. You guys are like, that is a greater than sign, Miss Gallion, and you are correct. Greater than signs look like that. Angle signs look like that. And I always screw them up. This one's a horizontal line, and I will try to be better. Okay, so angle A matches with what in the big diagram? Angle A matches with what in the big diagram? W. And then I have angle B matches to, let me draw my angle sign. Angle what? B is at the top here. What's at the top here? X. And my last one is C. C matches what in this diagram? Y. Okay, that's bad printing, but I'll get over it. Okay. So these are going to be the more thinking questions that we've done because we've done basic math in our lesson 1 and lesson 2. So these are our thinker questions. Did that make sense to everybody? Matching up the sides, matching up the angles. It's just stuff that looks the same. It's just a different, it's just either bigger or smaller. All right, so determine if triangle JKL, this means that the vertices are labeled JK and L. So JK and L is similar to triangle PQR. So it's asking, are they similar? All right, so we got to figure it out. It kind of looks like they're similar. They're both the same shape. They have a 90-degree angle. So that and that are equal, 56 and 56. Do you guys know the rule of 180 in triangles? Do you know what that is? Maybe we haven't taught it to you yet. But all inside angles on a triangle add up to 180 degrees. Doesn't matter what shape the triangle is, doesn't matter how big or how small. All the inside angles, all the interior angles add up to 180. So if this one and this one are the same as this one and this one, we know that this angle and this angle are the same. So that's a good indication if the angles are equal, that it is similar. But I got to prove one more thing. So what I'm going to do is I'm going to find my scale factor. And I'm just going to do it on one side. So I'm going to do the one with whole numbers. I'm going to do those two. Those are similar sides, right? JK and PQ are similar sides. So I'm going to find the scale factor for these two sides. So we're going to say this is the, I'll do this one as the original, and I'll do this one as the drawing. Okay, do we remember the formula for scale factor? Did you write it down from the example above? Drawing over original. All right, so the scale factor is 4 from my drawing over the original, which is 6. And that's going to, if I do the math on that, that's going to give me 0.6 repeating. It's going to give me 2/3. If I reduce that, I know 2/3 is 0.6 repeating. So in order to double check that all my sides are the same, I'm going to take 10.8 and I'm going to times it by the scale factor, which is 0.6 repeating. Now, if you don't do, I don't know why that isn't bright enough. This is kind of hard to see. Let me turn that off. Ah, there we go. Okay, if you don't put in the lots of sixes, so 10.8 times 0.666666666, okay? So if I don't put in a bunch of sixes, I'm going to get the wrong answer. So I get an answer of 7.2. So if this side is 10.8, if I multiply it by the scale factor, I should get the length of the corresponding side. So that's why it's important to know what sides match other sides. And does that work? That's good, right? That's good. So we have one more side to check. We're going to take 9 and we're going to times it by the scale factor. 9 times 0.666 repeating, and I get an answer of 6. So the 9 side matched this side, and that works out. So we can say that they all increase by the same scale factor, because we just checked that, and all the angles are the same. All That's angels. That's not angles. Let me try that again. All right, so all sides are reduced by the same scale factor, and we know they're being reduced because the image is smaller, and then all interior angles are the same. What do all 3 angles of a triangle add up to? 180. Remember that. That's going to be helpful. Grade 10. I don't know where you're supposed to learn that. We don't do a lot of work with triangles, but that's a secret rule. And it's not really written anywhere, but it is something that will be helpful for you later. Okay, everybody get that? Am I good to switch the page? All right. Okay. So, let me just outline this because it's kind of hard to see. We are going to draw a shape that is similar to the one given, but it has to be smaller. So you guys are going to make up a scale factor. What are we going to reduce the sides by? What's the easiest one to do? 2. We're going to reduce by 2. We're not going to, if we times everything by 2, we're going to end up with a bigger shape if we have a scale factor of 2. So if we want to divide by 2, how do we put that in as a scale factor? So if we use a scale factor that's equal to 1/2, that's going to divide everything by 2. All right, so if it's a fraction, remember that from yesterday, if it's a fraction, our shape's going to get smaller. So we want to be multiplying by a fraction. So if we want to divide by 2, that's the same thing as saying multiply by 1/2. All right, so this is nice and easy. So we have 1, 2, 3, 4. So that's 4. That's 2. That's 2. That's 1, 2, 3, 4. That's 4, 4. No, that's a 2. 1, 2, 3, 4, 5, 6. All right, if we know all of our side lengths and we're going to times them by 1/2, or we're going to divide them all by 2, what's this new side length? 2. Okay, there's my 2. If this one was 2, what is it now? What's 2 divided by 2? 1. That'll be 1. And this will be 2. And that'll be 1. And this should be 3, which it is. 3, 1, 2, 1, 1, and 2. Whew, that's a tiny little drawing. That's a little Tiny. Tiny. All right, pretty straightforward. Now we're going to draw a figure that's bigger than the one above. So that means our scale factor has to be bigger than a fraction. Has to be greater than 1. So what scale factor do you want to use? Times by 2, right? So if we have a scale factor of 2, that means we're going to times all sides by 2. Okay, this one's going to be a little hard because I'm going to just put that diagram up there. I hope you guys have all the dimensions on it. So if the side, the straight side was 4, what is it now if we times it by 2? 8. Perfect. So we got to count up 8. 1, 2, 3, 4, 5, 6, 7, 8. And if the top part was 2 when we times it by 2, where are we at now? 4. 1, 2, 3, 4. All right. And if that drop side was 2, it's now 4. So 1, 2, 3, 4. And if it was 4, you told me it was 8. So 2, 4, 6, 8. And then I go down 4. And then if it was 6, it should be 12. So 2, 4, 6, 8, 10, 12. Woo, thank goodness. All right, so pretty straightforward. It's just multiplying either by fractions to get it smaller or by a number greater than 1 to get it bigger. And sometimes we can pick the scale factor. Those are nice and easy. Everybody's going to be a rock star on their quiz or on their test. All right, now we get into these what look like really hard word problems, but they're not. We just have to think about it. Okay, so it says triangle is not spelled correctly. I'm having a hard time. I did an angel today. Just gonna flag that to fix that later. 2 triangles below are given the following information. It's telling you that triangle XYZ is similar to triangle ABC. So it's telling us they're similar. So right away we know they have the same scale factor. Oops, scale factor for all sides. And we know that all angles are equal. As soon as it tells us that, we know those 2 things. We know they have the same scale factor for all the sides, and all the interior angles are equal to each other. So angle X, let's write this in. It says angle X is 90. And so in math for 90 degrees, we just use that box. We don't actually even write a number on it. We just use the box. For angle B, we're at 50. And angle C, we're at 40. Find the missing sides and the missing angles from each triangle using the properties of similar triangles. These are the 2 properties, ladies and gentlemen. Those are the 2 things that when we're talking about properties, it is those 2 things. So let's do the angles first, because those are going to be the easiest to do, because they're the exact same. So what angles match? X matches what on this side? A. And I like to use color because it makes my life a little bit happier. Y matches B. And Z matches C. Right? Oh, those are pretty dark colors, but you get the idea. Okay, so if we know that angle X is 90 degrees, how much is angle A? All angles are equal. So if we know that X is 90, what's A? Also 90. So angle A is 90 degrees. If we know that angle B is 50, what's angle Y? Also 50. And if C is 40, what's Z? If C is 40, what is Z? 40. Okay, all of our angles are done. That was pretty easy. Didn't even have to really do any calculations or anything like that. Now, side lengths are going to be a little bit different. So we have to figure out what the scale factor is. So, this was a bad idea. I don't think I have enough colors. Okay, we know that YX matches BA. Right? And I got a purple here. Do I have another color? I don't think I do. We know that XZ matches AC. And I'm going to grab a red pen here. And we know that YZ matches BC. Oh, that's a very colorful triangle. All right, so now we need to calculate the scale factor. So what matching sides do we need to use in order to calculate scale factor? Anybody? So if we use this as the original, and we use this as the drawing, and it's always good to label them just so that helps our brain. So if we do scale factor, in order to do scale factor, I have to have both pieces of information. And the red side is the only side that has both pieces of information. So I'm going to have 9.93 divided by 14.9. So 9.93 divided by 14.9. Ooh, this is not a fun decimal. 666.442953. All right, so now we got to figure out the sides. If we go all the way back to page 4, these are important. So if I want to find a side length on the drawing, I have to take my scale factor and multiply it by the actual or the original side. If I want to find my actual size, I take my drawing side and divide it by the scale factor. So those two are super important. Let me write those down here. So we have drawing. If I want to find the length of the drawing side, I take the scale factor and multiply it by the actual or the original. If I want to find the actual side, I take the scale factor and I take the drawing and divide by the scale factor. So I need those two formulas from page 4 to do this. All right, so I have my original side. I want to find that one right there. I want to find, maybe we'll call it, that's side C. So this matches this, the yellow matches this. So if I have the original and I want to find the drawing, I'm looking for the drawing, so I'm going to use this formula here. I'm going to have side AB is equal to the scale factor 0.666 0.6442953. I'm going to times it by the actual, which is 9.58. And side AB, 9.58 is, and we'll round to 2 decimal places, 6.38. And what's my units on that? What's my units on that? Centimeters. Okay, so we know that side AB has a length of 6.38. Good job, everybody. Now, we want to find XZ. We want to find XZ. So we have the drawing side. We know that it's 7.61, and we want to try to find the original length. So we are going to take XZ is equal to 7.61 divided by the scale factor this time. 442953. And I always cross my Z's so they don't look like the letter T, or the number 2, just in case you're wondering why I do that. 7.61 divided by 0.3442953. That's going to give me 11.4, and this one's 11.418. If I want to go to 2 decimal places, what's going to be my second decimal place? Is it going to be a 1 or a 2? It's going to be a 2, because we look at the third decimal place, the 8, and the 8 rounds up the 1. So that's going to be a 2. And what are my units of measure? Centimeters. Ladies and gentlemen, you can expect to see a question like this on your problem set and on your test. Okay, so you can expect to see this on both those things. All right, so these are the thinking ones. You've done all the math before. Now this is putting it all together. So the evergreen tree below is 6 meters tall. And it casts a shadow of 5 meters. And we know shadows lie on the ground, so that's why I'm putting the 5 there. And the height of the tree is there. On the same time of day, the building casts a shadow that's 28 meters long. How tall is the building? Now we're going to assume that these shapes are similar. Hey, Mr. French. I'm recording a video, so... You didn't show up, like, to work?
Yeah.
Okay. Yeah. All right, more math. Okay, we're going to assume that these shapes are similar. We are going to assume that these shapes are similar. So we're trying to find the height of the building. So first thing we have to do is do our scale factor. I'm going to call this one the original. We're going to call this one the drawing. And I seem to only be able to write draw in there. I don't know why I feel the need to do it this way, but this is what I'm doing. So if we're going to calculate the scale factor, we need to pick the sides that we have the information for. So what's the formula for scale factor? What's the formula for scale factor? Drawing over actual. And if you don't know that, that's okay. It's on page 4. Make sure that it's on your cheat sheet. So the scale factor is I'm going to take the drawing, which is 5, and we always have to start with the sides where we have both pieces of information. All right, so what's 5 divided by 28? So that's my scale factor. That doesn't solve the question. I'm looking for, we know the height of the tree, we know the height of the drawing, but we're trying to find the actual height of the building on the original. So if I go back to my two formulas, I'm trying to find the actual, so I'm going to use that formula here. So I'm going to take the actual, so that's my question mark, is equal to the drawing divided by the scale factor. All right, 6 divided by... And what are my units of measure on this one? What am I measuring the tree in? Meters. And it's important when you're calculating scale factor that all your units are the same. And we did that yesterday with that ladder, that stairs, going down the stairs, you times by 10, going up the stairs, you divide by 10. So you want to practice that. All right, that is the last lesson of scale factor. I do have highlighters and colored pens on my desk. If that helps your brain, if you want to borrow some, you're more than welcome to. The cup on my desk is full. You're more than welcome to borrow whatever you need. And that's that. Unit done.